Kruger's Coffee. When are you going to send me my endorsement check? Didn't receive anything from you yet. All right, kids, here we go. Unit 1, Algebra 2, Common Core, New York State. Unit 1, Algebra 2, Common Core. Common Core just rolls off the tongue like... Don't get me started. Whatever. Anyway, here we go. This is day 8 of Unit 1. Unit 1, day 8. We are going to solve equations, systems of equations, graphically, using our graphing calculator as a tool, as well as, I believe, let me look. Oh, it's exciting. Algebraically. Oh my gosh, I'm so excited. This is going to be such a fun day. None of this is new. It's all straight from algebra. The calculator part's a little bit new, so pay attention. Let's get started. We got to bring out our old guy named Mr. Key. Mr. Key's not going to make any mistakes. Yeah, right. Let's see. This is Monday, Tuesday, Wednesday, Friday, and Monday. Oh, good. I'm gonna be done with the whole week. Okay. Points of intersection graphically. It's where they hit. That point of intersection is 0, 1. Bam, done. That point of intersection right there is -2, -3. Finished. This point here is 0, 2, and of course then this is 2, 0. Not hard. Not hard. This point here just ate a little bit, so I'm a little bit burpy. I don't know why. 4, 0. And this point is 1, -5. These are points of intersection. These are intersection points. When you have a systems of equations, they're also called the solutions. And we've talked about yesterday, and we used it right here. We also said it's when f of x is equal to g of x, when those values are equal to each other. Let's move. So here are the directions. Again, if you need my notes, mrkrausemath.com, K-R-A-U-S-E, mrkrausemath.com. It's M-R-K-R-A-U-S-E, math.com, all one word. Go to classes, set 2 probably, set 3 or 4, doesn't matter, and then pick on the day. This is day 8. Now, we're going to use our calculator to determine this, and I'm going to show you all those steps above using the calculator, but I want you to have a copy of them. In order to use your calculator, you still need to be able to solve for y. Well, the first one's pretty good. We have already got it in y equals mx plus b form. This one's not quite so good. We need to move the x. So I get -x plus 6. And then I'm going to divide by 3. So I get -1/3 x plus 2 when I divide everything by 3. So these are the two equations that I'm going to graph using my calculator. So I go to the home screen, click on graph. And my first equation is, let me get my notes up so I don't have to keep flipping back and forth. I believe it was 2x minus 1. Where am I doing with these things? My coffee's in the way, and nothing's getting in the way of my coffee, you know what I'm saying? 2x minus 1. Burgers. That's really hot. 2x minus 1. Kabam! Nice color of blue. I think the next one's red. Sometimes you can grab this thing, and move this label, make it look all pretty, put it in place. I don't know what the other one's going to be, so let's put that there for now. To get a second graph, we press the tab button. So we're going to click on tab, and this time we're going to type in -1/3. To get a fraction, we're going to do control division, -1. Make sure you hit the negative button, not the minus. -1 divided by 3, x plus 2. Enter. Bam. Now, right here is the point of intersection. Now, there's a couple of things you can do. I'm going to show you the way we did it on the paper by going into menu. Menu is a great button. Lots of stuff underneath menus because there's lots of buttons. Like this button's cool, that button's cool, lots of cool stuff. Look at all this stuff. And each one of these that you click on's got stuff. So what do we want to do? I believe we want to analyze the graph. If you even see it, you see a parabola and a line here, and they're going to analyze the graph. And there it is right there. We want to find a point of intersection. So what this little curvy line says, or what the straight dotted line says, what's the lower bound? Now what that means is, here's the point of intersection. Lower bound means get to the left side of it. The x's are to the left. The lowest side of it, we're going to go to the left. And then, where's the upper bound? We're going to go to the right. So here, click. We'll hit here, click. Now it says, okay, what's the upper bound? See over here it says upper bound? So what you want to do is make sure that that point gets highlighted. Go to the other point. Eventually the word intersection will appear. And then click again. And put this label up here. Oops, what happened? Bring that label up there. It should be in red. Okay. And here is my point of intersection. Now, if you think you'd be able to find that algebraically, yeah, you probably could. Now, notice it's got 2 decimals here. That's a problem. I don't know what they ask for. Did they say round? Normally, I'll tell you to round to the hundreds or thousands, and they can get crazy, but we got to change the settings on this. That's not good enough. See this float 3? We don't like float 3. First of all, we don't like radians. This should be in degrees. But float 3, we want this to be in auto mode. And we're going to choose to make that the default and click OK. So now what you actually get are the actual solutions to this problem. 1.28571, 1.57143. And now you can round it to whatever place value you would like. So let's go to the tens place. 1.3. So 1.3 comma 1.6. So those are my 2 solutions. All right, let's try this one. Now I don't like giving, I forgot, Doc B. Somebody said you can click on Doc B, clear scratch pad. Well, it works now. I don't know why it didn't work the other day. So anyway, I just like hitting the red X, to be completely honest with you. Let's hit the graph. Let's go to the graph. So we are going to graph the absolute value of x minus 4. Now remember, this is where the absolute value bars are, right here. Absolute value of x. I don't know why that's happening. Minus 4. And hit, oh my gosh, I forgot x. And then the minus 4 is on the outside, so I got to click on the outside and then do minus 4. And clearly that's just a absolute value that got moved down 4 units. It was a translation down 4 units. And the other one we're going to do is 4x plus 2. So we hit tab, 4x plus 2. All right, so my point of intersection is right here. There it is right there. Here's another way to get the point of intersection. I think you can go menu, trace, graph trace. And you see that little blinking alien? I click, and I click, and I think it'll stop actually on the point of intersection. No, it doesn't. I think it'll stop on a 0, though. There it is. It stops on zeros, but it doesn't stop on points of intersection. So I guess this isn't a way to do this. It's kind of a cool thing, though. Anyway, so let's get out of that menu, analyze graph, intersection. Get to the left, get to the right. There it is. Once again, for some reason, looks like it's rounded. Maybe those are the exact answers. I'm really not sure, but I want to make sure that we didn't get to rounded mode. Display digits. No, that must be the exact answer. Cancel, cancel. Oh, man, why did I go to float 5? Cancel. All right, so those are my exact answers. Negative 1.2, negative 1.2, comma, negative 2.8. There's my 2 answers. And that's it. That's all there is to finding it using the graphing calculator. Like, oh my gosh, I can do that. I can do that. All right, don't get so excited. We ain't making it that easy on you, bro, and your sis, whoever's out there. Oh, son of a popsicle. Look at this. Solve algebraically. Now, you can solve it graphically, but we're going to do it algebraically. We're going to use the substitution method because generally that's the easiest method to do. And so what I want to do is I want to solve for one of the lone variables. And I'm going to solve for this y value right here. I'm going to get this y all by itself. So the first equation is just what it is, but this thing I want to get by itself. So what I'm going to do is I'm going to move that y to the other side, and I'm going to move this 4 over. When that 4 comes over, it becomes minus 4. And when the y goes over here, it becomes positive y. So I know everywhere I see a y, I can replace it with that. So what I'm going to do is I'm going to take this first equation, 2x plus 2y equals 16. That's my first equation. And I'm going to replace the y. I'm going to replace the y with what it's equal to. 3x minus 4. Because that's what y is equal. Y is equal to 3x minus 4. So I'm going to solve this. So I get 2x plus 6x minus 8 equals 16. And do a little fun stuff. I'm going to combine these x's, 8x, and move the 8 over all at one time. And I get x is equal to 3 by dividing. But that's not good enough. Points of intersection have an x and a y. So what I'll do is I'll come over here and I'll say, okay, 3 times 3 minus 4 is equal to y. I'm going to take this 3 and plug it into this equation. Well, that's 9 minus 4, so y is equal to 5. So it appears as if my answer is 3, 5. There's my answer, clearly delineated or shown. That's hot, but I like to check my answers because I am a checking fiend. And earlier I made a mistake, which was quite embarrassing. So instead of 2x, I'm going to write 2 times 3 plus. Instead of 2y, I'm going to write 2 times 5 because those are the x and y values. And I'm hoping this turns out to be 16. Notice I'm checking it in this equation. And if you do that, you get 16 equals 16. You smile, you get all happy. All right, this one's a little bit easier. I already have what y is equal to. I don't have to do any preliminary work, so I'm going to replace that y right there. So I'm going to do 3 parentheses 2x minus 2 minus 3x equals 9. So this gives me 6x minus 6 minus 3x equals 9. 6x and minus 3x is 3x. Bring that negative 6 over by adding it over here, and I get 15. So I get x equals 5. All right, plug that into this equation. Y is equal to 2 times 5 minus 2. So y is equal to 8. So my answer, clearly delineated, is 5, 8. Now, I'm hoping I didn't make any mistakes. But I want to check it. So I'm going to set it, instead of 3y, I'm going to write 3 times 8 minus 3 times 5. Does that equal 9? Well, this is 24 minus 15. And yes, 9 equals 9. Catching. Done with that one. All right. We don't have what y equals. This is probably the easier one to find. So I'm going to say y is equal to x plus 3. This is y, and I'm going to plug it in there for y. So instead of x squared plus y, I'm going to write x squared plus x plus 3 equals 5. Oh, I'm so excited. Factoring. The F word you're allowed to use in math. Fun. Fractions, and my favorite is factoring. How do I know I have to factor? I have an x squared. Make sure your x squared is always positive. We're going to bring this 5 over. It has to be equal to 0 in order to solve a quadratic. Ooh, that's such a great word, quadratic. And by the way, just so you know, this means we have a parabola, which is this one, and a line, which is this one. So we could have at most 2 answers. Sometimes you don't have any. Sometimes the parabola and the line never hit each other. Sometimes they only hit each other once. And lots of times they hit each other twice. Looks like I'm drawing like a guy here. Woo! Yeah. That's his chin. Got some ears. Woo! Look at that. Some ears. I'm drawing a dog with glasses. All right. Oh, man. I am an artiste. Anyway, let's keep going. Plus x minus 2. Equals 0. I'm subtracting 5 from both sides. A little factoring fun. Oh yeah, I said fun with factoring in the one word. That's like 2 F's in one word. X and x. They have to multiply to negative 2, add up to positive 1. And so that's only one way to multiply to negative 2. Negative 2 and positive 1. Wait, that's not going to work. Why is that not going to work? Well, although it has to be 2 and 1, Negative 2 times positive 1 is negative 1 when I add them. I need this to be positive and this to be negative, because now when I add these two numbers up, I get positive 1. So my two x answers are x equals negative 2 and x equals positive 1. But for every x, and I want my answers, I know my answers now are going to have two answers. I've got to have an x and I have to have a y. So x and y, x and y. So I'll bring down this equation, y equals x plus 3, plug this in, and y equals negative 2 plus 3, so y equals 1. So my first answer is negative 2 and 1. My second answer, y equals x plus 3, plugging this in, I'm going to get y equals 1 plus 3. So my second answer is 1 comma 4. Now, if you don't like this or you want to make sure that you're right, you could do this. You could say, okay, this is y equals negative x squared plus 5. And this we figured out y equals x plus 3. Now what I did was I solved both of these for, y. And I could go to my calculator and say, okay, let's do doc B and calculator mode. And we'll go into negative x squared plus 5, enter, hit tab, and we'll do x plus 3, enter. And we can do points of intersection. So menu, analyze graph, and intersection. And I can go left bound. Now there's one point, negative 2, 1. There's the other point, 1, 4. 1, 4, negative 2, 1. 1, 4, negative 2, 1. And notice then I have two answers. And there they are. Okay. Thanks, guys. Thank you. By the way, anytime you see... All right. Come on. Uh-oh. Might be in trouble here, kids. What the heck? I almost said, what the fraction? What the fun? All right. I'm going to solve this one for y. So I'm going to move this over, and I'm going to move this back. So I get 3x minus 3, because that 3 comes over, equals positive y. So now I know what y is. So I get 3x minus 3 plus x squared equals 1. Again, your x squared always has to be positive. So I'm going to clean all this up, x squared plus 3x. And I'm going to bring this 1 over. Remember, when it comes over, it becomes negative 1. I'm going to put it with that one. So minus 4 equals 0. Factoring is quite simple here, kids. I mean, if you can't factor this, we got to take a little trip back to 9th grade. Oh, yeah. Wayne's World, Cross's World, Cross's World, math rules, plus 4, minus 1. They add to make positive 3, and they multiply to make negative 4. My two solutions are x equals negative 4 and x equals 1. But remember, those are only half of the answers. And I'm not checking these answers, by the way. I am going to just tell you they are correct or not correct. So now I want to find out what the other one is. So I'm going to take this equation that I have, y equals 3x minus 3. I'm going to plug in a 1. So y equals 3 times 1 minus 3. Oh, that's 0. So one of my answers is 1 comma 0. Well, that's okay. Y equals 3x minus 3. Now I'm going to plug in this other answer of negative 4. So I get y equals 3 times negative 4 minus 3. And to save a little bit of time, we're going to just say that's negative 15. So my other answer or solution or point of intersection is negative 4, negative 15. Math is awesome. There's a mistake I made in there. Oh, we got to graph these. We're going to do this graphically without the calculator, but then we're going to check it using the calculator. So this one I will graph in red. It's all ready to go. My vertex is 6, 1, and I have a slope of 1, and it's going up because it's positive. That's just giving me my planning. I'm just planning it. I'm just going to draw this while I drink some coffee. So positive 6, 1, 2, 3, 4, 5, 6, 1. There's my vertex. It's got a slope of 1, and it's going up. So it's going to go like this. I did it like this. I did it like that. I don't know what I'm doing with that math. There we go. So that's my red one. Let's bust out the blue. Now this one's not quite ready to graph. We'll move that 2x over. And now it is. So it's got a y-intercept of 6. 1, 2, 3, 4, 5, 6. And it's got a slope of -2. Down 2 to the left 1. 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 Down. Now this one is another one that could possibly have 2 solutions. Many, many times it does. In this particular case, it looks like it's only going to have 1 solution. And that's some... That's a sick drawing right there. I'm telling you. So, wow, that was amazing. So it looks like my solution, which is in fact right there, is 1, 8. Excuse me, -1, 8. I'm going to check it using a graphing calculator. So I'm going to check it. We're going to clear out Doc B, since that seems to be working again. And go into graph mode. And we're going to do the absolute value of x. I totally forgot what this is. -6 outside plus 1. Enter, tab, and then it's -2x plus 6 and graph. Oh my gosh, I can't see what I'm looking at. I can't see, so sometimes you just grab the graph and do this. And there it is. Now let's just check. Menu, analyze graph, points of intersection, click, click, there it is. -1, 8. Oh my gosh, it's a beautiful thing. So we're going to solve this system of equations. Here we go. So we don't like you very much. Okay. So we're going to solve this system of equations. I already have what y equals, and I already have what y equals, so I'm going to sub in. I'm going to sub this in for y. So I'm going to do 2x plus 5 is equal to x squared plus 2x plus 1. Now you never want to have an x squared, so both of these are coming over, and they're going to be negated or subtracted on the other side. So we get 0 is equal to x squared. Now wait a second. When I subtract 2x here, those go away. And I'm going to subtract 5 here. I get x squared minus 4. And I love that. That's easy. It's the difference of perfect squares. Right, Minahanny? Oh, yeah, Minahanny. You know what I'm talking about. If you don't have me as a teacher, you must think I'm a little bit off my rocker, which you'd be okay with. Remember, when you have the difference of perfect squares, these multiply to x squared, these multiply to 4, one's plus, one's minus. So my 2x solutions are -2, and x equals +2. Okay, still got to find the other one, so let's plug it into the second equation. I'm going to change to red because it's a lot more festive. So y equals 2x plus 5. Plug in the -2, and you're going to get y equals 1. So -2, 1 answers -2, 1. And y equals 2x plus 5. This is going to give me y equals 9. So my other solution is 2, 9. Yes, I did it. I got it right. I'm so smart. All right, let's graph this one in red. So we're going to get y equals -x plus 1. I hate when it's -x because it's always got to hit every corner. And we're coming down. Boom, boom, boom. All right, let's just see if I can do this. Oh, that's like almost a straight line. This is just me being really lazy. Oh my gosh, that's close. All right, so this one we're going to do in blue. Let's do it in green. So this one is the absolute value of x, so it's got no left or right movement because there's nothing being added or subtracted here, and we're just going down 4. So 1, 2, 3, 4. And it's got a slope of 1. That means it's going to hit all the corners of all the boxes, which really is quite aggravating. So these two lines are parallel. So they'll never intersect there. They both have a slope of 1, and they will never intersect. So this is my only point of intersection right here. I'm a little worried about it, though, because it's halfway between this box and it's halfway between this box. And I'm intrigued. We can't ever have halves as answers. It really appears as if my solution or my answer is 2.5 comma negative 1.5. That looks like what my solution is. That can't be right. Let's go grab the calculator, Doc. Be it. Go to graph, and we're going to do negative x plus 1. Bam. And the other one is tab. What the heck did I hit that for? Escape. The absolute value of x minus 4. Oops, lost my first line. Tab negative x plus 1. All right, there's my point of intersection. Let's menu analyze it, and we're going to do a little intersection. Ka-cham, ka-cham. Uh-oh, can't see it. There's my point of intersection. Yay, decimals. Decimals are our friends. There's our solution. And we'll draw a little fancy cool thing around it. All right, kids, I think we're on our last 3. Oh, I jammed 3 problems into this one. Okay, this is y. So I'm going to plug it in for there. So x plus 1 equals x squared plus 2x minus 1. We're going to bring these over. So now we get 0 is equal to x squared minus x minus 2. 0 is equal to x minus 2 and x plus 1. That's the factoring. They multiply to negative 2, but add up to negative 1. So my two x answers are x equals 2 and x equals negative 1. Now to find my y answers, we're going to use this equation, the second one, y equals x plus 1. So in this case, when I plug that 2 in, I get y equals 3. Y equals x plus 1. When I plug that one in, I get y equals 0. So my two answers are 2, 3 and negative 1, 0. By the way, if I'm going too fast, hit the pause button. Do some of the stuff on your own. You want this document? Go to mrkrausmath.com and download it. Print the thing. Do something. Stop watching my ugly mug on your computer screen. I mean, seriously? Isn't there a Vine you should be watching? Shouldn't we Snapchat or Twitter or tweet or Facebook or something with some of your friends rather than watch this? Do some work, bros and sisters. Where am I going? There it is. Ka-cham. I'm going to do this first one in red. It's got a vertex of negative 4. Remember, that's backwards, comma, negative 1. It's going to be opening up down, but it's got a slope of 1. But opening down, it's kind of like the slope of negative 1. All right, so my vertex is negative 4, negative 1. 1, 2, 3, 4, negative 1. It's opening up down, but has a slope of 1. So we're going to try. I can go this way pretty good. And we're going to go this way is not so much. There it is. That's the first one. Now the second one, let's draw this in, let's go to green. Y equals x minus 1. Got to scratch my nose. So my y-intercept is negative 1, and my slope is positive 1. Boom, boom, boom. Well, I'm not going to go that direction. I mean, I can go that direction, but My point of intersection is going to be, looks like it's going to be right there. And this looks like it. That looks like -2, -3. -2, -3. Let's see if what that looks like on the calculator. So we'll doc B it. And we'll go back in. Let's see what we got here for this one. Negative, be careful, negative absolute value of x plus 4 minus 1. Enter. Bam, that looks like, oh, I did a good job. Tab, x minus 1. X minus 1. Enter. Now I got a menu. Analyze it. Intersection. Ka-ching, ka-ching. Good enough. -2, -3. Is that what I wrote down? Did I write that down? -2, -3. We got one left, my bros and sisses. All right, what do we got here? All right, this is pretty easy. Y equals 2x plus 4, because we're going to bring this over here, right? So there's y. I'll plug it in there. So I get 2x plus 4 minus 1 equals x squared. Now, you never want to have a negative x squared, so don't move this. If you move this, I'm going to beat you senseless when I see you. Be like, Mr. Krause, I moved the x to make it negative, and I'll bam, hit you right in the head. I don't even care. I'll lose my job. You'll go down. Oh yeah, what are you going to do about it? You can't jump to that video camera. This is nothing. Everything's going to this side. So 0 is equal to x squared. Always want to make sure x squared is positive. Minus 2x, because that 2x comes over, it becomes minus. Now this is positive 3 on this side, so it goes over there, it becomes -3. Oh, look at that factoring. It looks so beautiful. I think I can handle it. Multiply to -3. 1 and 3 somehow. 1 and 3. They got to multiply to negative, so one of them has to be positive. And we want them to add up to negative, so this will be positive 1. I don't know why I put that there. And this will be -3. So my two solutions, or my two x values, are -1 and +3. So now I want to check. Here I'm going to use this equation right here. We'll grab some red. And my equation is y equals 2x plus 4. So I get y equals 2 times -1 plus 4, and that's 2. So one of my answers, and I'm not really confident about these, I think I am. One of my answers appears to be -1, 2. I think this is the one I made a mistake on earlier, and I was kind of embarrassed about it, so I want to make sure I fix it. And then my other one is, let's see, y equals 2x plus 4. When I plug that 3 in there, that's 2 times 3 plus 4. So that looks like it's 3, 10. And this is going to give me another opportunity to show you. So one more thing on the calculator. So we'll doc B it. Go to calculator, and then we're going to type in 2x plus 4. Enter. Now if I go back here, I didn't quite solve this one for y. This one is y equals x squared plus 1, because I bring the 1 over. So if when I tab this, I'm going to do x squared plus 1. Bam. Now, can't really see it, so I'm going to drag it. Now if you don't see that, and you just see this, you can also go to menu, zoom. What the heck is zoom? Menu, window or zoom, and just zoom out and just click somewhere. Zoom out. Ah, there we go. So now I can do menu, analyze graph, intersection, and I can go here, click, and then go here, click, and there's one of them, -1, 2. I think I said that. And then just do it again. Menu, analyze graph, intersection, click on the left side, click on the right side, and 310. Oh my goodness, kids. Day 8 is over. That was day 8. So we've now finished 8 of the 12 days that we have to go. Maybe it's 13. Not really sure. Anyway, that's that. Day 8 is over. Congratulations. And we will be starting day 9 very shortly. Again, hit the subscribe button if you like. Follow me on Twitter. I don't even know what my Twitter handle is. Don't worry about that. Just subscribe. We're good. Bye, guys. Catch you on the flip side.